All right, we have a full house for today's conversation. Steve, Jeff, Randy, good to have you here. Steve, this first question's going to go to you. One topic, surprisingly, we really haven't discussed directly on this show before is metrology. So let's start with a basic definition. How do you describe metrology as if you're having a beer with someone?
Well, it's a good question. And for many, many years, I didn't know what metrology actually was myself. It's not meteorology. That's probably the biggest mistake everyone makes out there, right? If I could tell the weather, I'd probably have a different job. But so it's not meteorology. Metrology is it's a science of measuring things, right? It's the simplest kind of way of thinking about it. And the things I'm involved with, and I think you guys as well, is more about industrial metrology, right? So it's ensuring the accuracy, reliability of the things we get involved in producing. So it's kind of a quick answer, I think.
No, it's a quick answer, but it's a good answer. It sets the baseline science of measuring things. Today we're talking about it in the context of industrial settings, and in true manufacturing happy hour fashion, I think it's best that we start with like a story told over a beer, if you will. And you all have extensive experience in this space, but Jeff, I mean, you've done projects ranging from like Madison Square Garden to TSMC, the Texas Rangers baseball stadiums, Vegas Sphere, you name it. You've been around the block. How do you utilize metrology to get better information in the projects that you do?
Well, the bottom line is it's all about the numbers. It's one of the favorite sayings is in God we trust. Everybody else has to bring good data, and the data that you get with metrology. I mean, I got a lot of conversation. We were in a 45-minute meeting, and I left 7 hours later at U.S. Steel yesterday, and talk about the definition of what is metrology, what are surveyors, and I'm telling you that lasted an hour. And but we just use the metrology, the study of the numbers, and for verifications, and it's just my saying to all my guys all the time is verify, verify, verify. You know, and that's just the science of numbers. You just got to find the accuracy. You got to use different systems and types just to verify, even if it comes down to a tape measure.
And Randy, you're doing a lot of like on machine inspection with like spindle probes, etc. How are you leveraging inspection to reduce scrap and like make the best parts possible? Slightly different intro question for you. I'd love to hear like a boots on the ground story from your perspective.
Yeah, I think one of the easiest and the simplest ways that we have been and are using probes and inspection is just for simplifying setups. Right? If you let's say you've never used a spindle probe on a machine and you're new, the software out there is really pretty easy to use. And if you're just simplistically want to pick up your first operation, maybe you've got some stock that the saw cut links are vary quite a bit. You can use probing cycles to come in and find that and find the center line so that when you're, let's say, milling the outside of it, you're always taking an equal amount off of each side. And then conversely, operations that move thereafter, if you're picking up datums or you need to you want to pick up a specific feature on the part, it's nice such that maybe now I don't have to build tooling or fixtures that are extremely accurate. I can let that float a little, or I'm not really concerned about it because the probe is going to come in, it's going to pick it up every time, and necessarily I don't have to worry about it now. Right? Those are just the real low hanging fruit, easy things we can implement. Just right now with very little effort and training. On the other side, if we talk about pallet systems and automations, right? We've got a machine maybe running overnight that we've got a critical feature we want to check, and if that feature is undersized, no problem. Let's probe that. Let's comp the tool, and let's recut it. And then on the other side of that, if we oversize the feature, necessarily one could argue there's almost no point in continuing, right? We should reject that pallet, set a flag, reject the pallet, notify the operator, hey, I've got a problem, come take a look at me, and then move on. And most automation and pallet systems will have a setting or a feature that I can bring in the next job so that it's not just sitting. So I think regardless of kind of the parts you're making or what you're doing, real-time inspection and feedback is really just it's critical, and it can save you a lot of time and aggravation.
So you've all just given definitions or examples of, measurement, inspection, and more importantly, like the importance of having data in all of this. So I'm going to go a little bit of a different direction with this question, because I think some people misunderstand these topics or misuse them in industry. Jeff, how do some people use the metrology? I'm doing air quotes for folks listening on the audio podcast versus how should you actually use metrology? Let's go there.
Well, metrology, you're looking for the best data to make decisions off of. And, it is a science. It's a study of numbers, and you're looking at small deltas. You're looking for reliability. You're just looking for confidence in how you're installing machines, how you're erecting steel, how you're fabricating steel. Is it in the right location? What is it going to do? It's a science. It's a study. We track fabrication jobs all the time we want to understand what is heat doing to it? What is, cold doing? What is the weld procedure? What is all kinds of data that metrology is used to measure I call it the changes or deltas in a process.
Okay, so you're looking at measuring welds, cold, heat. I want to expand on that a little bit more. If you're not measuring that, what is the danger to, let's say, the project that you're working on? Give me an example there.
Well, okay, the trellis is the outside area of the sphere where the outside screen goes on. We fabricated that within the facility to plus and minus of a 32nd. By the time it got to the job site, you had to drive through the desert. You had vibration. You had heat. You have cold. If anybody's been around the desert, it's cold in the morning and it's hot in the afternoon. I can be burning up at 90 degrees and looking at snow caps. It's just the temperature variation is huge. And then one of the steel erectors wants to know why in the heck who in the heck did this metrology back at this shop, because we're 1 inch off, but we start monitoring that to understand what travel's going to do, what heat is going to do, what cold is going to do. Steel has a stress relieving properties to it, and how you treat that and how you deal with it is everything that you need to know. Most of the time that if you're out on a large job site, they fly things into place early in the morning before the sun comes up. And that was all due for all the measurements that we took. You're crazy as heck to fly something in the afternoon or when the sun's shining. Expansion is much worse than contraction at that point in time.
So I'm gonna paraphrase this as if I'm having a beer with you. The reason this is so important and that measurement is so important is because by doing it, you can account for some of these potential changes and you can plan for the project accordingly. You mentioned the different ways to treat the steel, etc. So that way you are well prepared for the changes that occur due to material science. Is that correct?
You're trying to do all you can to help these steel erectors out.
Love it. Great example. Steve, you actually got your start working in the jet engine space, but you've been focused in metrology for quite a while now. You've mentioned that it touches everything. Just give us that quick, we're at the conference happy hour. Give us an example of the breadth of metrology in this case.
It's a great consideration. Really, everything we touch in our everyday lives that is produced at some factory somewhere in the world has to typically be measured. Um, when you get up in the morning, it's going to be all the stuff in the home. It's going to be your coffee pot in your car, in your cell phone. Everything we use today, we don't often think about how it's produced. And virtually all of these things that we use are measured as part of the production process. Jeff reminded me of a story when it came down to building an airplane. All right, so think about building an airplane. Um, Oftentimes, the components of the airplane are not just produced in one factory. They can be produced in different countries. Fuselage in France, the engine in the U.S., the tail in Germany, and it's really metrology is used in all these different areas to monitor the production and dimensional geometry of all these parts. So when they do all come together for final assembly, they all fit and match. Imagine you're going to assemble the airplane and you're off by an inch when they come together. You've got a problem. You can't grow or shrink these parts. So the metrology is again used in all these different factories, and they're used locally to control and understand how well you're making your part. And then that same data is then shared to the end assembler to put it all together and make sure it's all going to fit. Um, One other thing I think has changed a lot is that we used to take and build parts or products, and once they were all done, we'd send them off to CMM lab, and the guy in the white lab coat would measure the part and say whether it's good or bad. And that is now changing. That's kind of an offline approach. We've gone from offline to now a nearline, and then inline. So we take inspection in process as we're producing the parts, so we don't actually produce scrap. Much more efficient way of running an operation. So I've seen a lot of technology used to go from measuring the product after it's all done to verifying the product in process, so you can monitor your process and not make scrap or rework.
So I actually think that's a nice preview to what might be the answer to this next question. How does metrology help manufacturers make the best products they can possibly make?
So another cool example. We do a lot of work with all of the NASCAR teams. Okay, NASCAR every single week they're going out there to go fast and win the race. And years ago, each of the race teams would produce their own car. They would produce their own chassis. They would produce their own body panels, staying within the conforms of the NASCAR rules. And that made a lot of potential for how good of a car you made, whether you won or lost every week at the racetrack. That's all been changed now. NASCAR is trying to have parity with all their teams. One company produces all of the carriages and the body panels and all that. So what some companies are doing is they're using our technology to measure every single part they receive. Now, in theory, they're all exactly the same, produced in the same factory for all NASCAR teams. But they're measuring all these parts that come into their factory, understanding which ones are big and small and twisted and curved, because they're all not perfect. And they're taking all that data and they're optimizing what they have received to build the best car each week. So it's a great example of trying to stay ahead of the other teams using metrology data to optimize the best build of their cars each week. And the teams are doing this, and using this technology are winning a lot of the races.
Excellent story. Excellent example. We're gonna go a little bit beyond metrology now, and Jeff, I've got another question for you. And I'm going to start with a quote, I believe, that you had mentioned to me before we recorded this interview, is that you mentioned years ago that one of your professors said, "People only give a crap about results." So let's go into this. Today, one of your key results, your clients, that they measure you on how fast you can get a job done. And this is pretty typical across the manufacturing industry for projects. What is your secret to getting jobs done as quickly as possible? Maybe how does measurement tie into all this?
Well, it's like I said, we had a very long meeting at U.S. Steel yesterday, and there were a lot of questions of how do we get results faster, and when you stay up with the technology. I mean, probably 80% of these guys have never seen a Leica tractor in their lives. And they got introduced to the ATS 600 and the AT 500. And they were just like, holy crap.
Define that for our audience. I'm not sure everyone might know what those are.
Well, they took us out and they wanted us to check an alignment of a roll, and it's on a what they call a cold mill line that's getting ready to be commissioned and everything else. He says, I want to see how fast you can get the alignment into the control. We had control. Well, they were impressed with the startup time, for one thing, of the equipment. Most of our competitors take 45 minutes to an hour to warm up. We went out there, started up. We set control with the AT 500 because it goes 500 feet each direction. So we had a high level of confidence, and then we tied in the AT 600 to do a scan on the roll. And we had all the data and information within 35 minutes. They said the competitor always takes about 4 hours to do this.
There you go.
So it's all about the process, and no substitute for knowledge either.
Yeah. We're going to get into some of these tools and the importance of having the right technology a little later on. You've also mentioned that a lot of your success at Industrial Technology Solutions has been in reliability as well. How does that translate to results, and what can other manufacturers learn from your approach? Because I'd like to make this actionable for them.
Well, understanding the process is going to be key to what I go in, because it's just kind of dealing with the vital few items versus the trivial many. And we kind of put that, we're all statisticians, and, we have a good background in mathematics, statistics, engineering, but if you got to go after the vital few areas that are kicking people in the rear end. And most of the time it's always rework and other areas. And it's pretty easy to find up front. But when you have equipment like what we have now, we do what we call a lot of crane evaluation. Well, we don't have to shut things down. And I get so many managers and people out there saying, you realize if we shut this down, it's $1 million an hour. And, I get so sick and tired of hearing that. I didn't put them in that position. We're trying to help them get out of it. But having the right statistics and data going into a project is very, very important. But that's what we do a lot of as well. That brings the reliability side of things.
You mentioned something that, and Randy, I promise we're going to get to you after this. You've been chilling with us for a while here. We're going to get to you next. But last question I've got for you, Jeff, for this train of thought is, you talked about rework and eliminating rework. So the manufacturing leaders listening to this will love this one. What are you doing to essentially take the rework that you have to do on projects to zero?
Well, you're training your fitters. You're training everybody to utilize metrology. You cannot wait to inspect all your parts, especially in the fabrication shops, when they're done. If you don't catch it during the process, it's going to end up in rework. And the whole idea is to teach millwrights, steel erectors, fabricators, fitters, everybody that's doing this, how to utilize metrology, when to call it in. Because believe it or not, there are tape measures that are not in tolerance out there in the field. So, people laugh at me when I say we're going to take it to zero. But we have a 40-year track record that can prove that we can do it. And it's a mindset, and I talked about it earlier. It's a paradigm shift.
Well, we're going to talk about that paradigm shift, that mindset, the training that goes with it, because you're teaching people to catch it during the process. Randy, as we transition to, let's say, this training conversation, How are you also leveraging tools on your side? Like a spree, for example, to be as efficient as possible, especially when folks have to compete on like a global scale?
For myself personally, especially, we were talking a little bit about on machine probing and inspection. Spree has they have an add-in or an add-on, like a tool that comes with it that you can use to program the probes in the system itself, and then so that you're not, hand, like previously we used to just kind of hand code that stuff. It was just kind of how the job went because it wasn't really well supported in most cases. And now, Hexagon has done, in my opinion, an outstanding job of taking that, putting it inside the software. We can simulate it. We can see if we're going to crash into something or if we have the clearance we need, and we can build that, into the program. Going into the program with that mindset and not as an afterthought. We see tolerances we need to hit, or key criteria or features, whether that's locating on tooling on our next op, or maybe a tight tolerance hole, or some kind of a feature that if we blow it, we're either going to have to, like Jeff said, rework it, which could be very painful and costly, or we could totally scrap the part and then just waste all that time and material that we just spent however deep into the process we are. And so I think just as manufacturers, I think we need to kind of allow for that time to be in the process, and let's not I think, like Jeff kind of alluded to, let's not wait till we find the problem to start addressing it. Let's look at it with a little more forward thinking and forward thought and say, if this did go out of whack, this could cause us a lot of pain, delays on the delivery, loss of goodwill with the customer, loss of cash, all those things that we want to avoid. And so I think that, again, with that paradigm shift and that mindset, we need to remember that it has value, right? That it has value at the front end and not just on the back end. And so I think, until we really accept that, I think it's, we're going to trying to chase the being reactionary versus, proactive, is, just something that we really will benefit from, I think.
Well, let's continue talking about tools to be proactive. Steve, this question's for you. You mentioned in a past conversation that attracting and retaining people involves being flexible, providing training, and providing access to modern tools. So that last one is the one we're going to tackle here. Can you share how you or others in the field are leveraging access to modern tools as part of your people strategy?
Sure. I've got a great job, right? So I run our factories here in the Americas. Hexagon has all this technology. So whenever we acquire a company with a hardware, software technology, I'm on the phone saying, hey, how do I get that in my factory, right? So, Spree is a great example. We have a machine shop here. We would produce all of our high value add machine parts. It was not a couple of years since I was here, I realized some of these programs were 20 years old. They hadn't been, reviewed in a long, long time. Along comes a Spree with a great set of tools. We were able to really analyze that process. We created a digital twin. So basically, we designed a digital image of the process we're actually running. We were able to simulate different cutter paths and different approaches to machine these parts, and do all that offline without affecting the production of the factory, and making all of our mistakes in a virtual world where you don't crash machines, you don't crash parts, you don't hurt anybody. And that was a couple of things. It was, of course, a huge boon to our productivity to be able to revolutionize our programs, make them much more efficient. But it also becomes a great tool for our employees to learn that technology that they can apply now here or wherever they might go in the future. NC Simul is another one of our simulation tools where a workstation trainer can be used to simulate different controllers. So you can basically virtually run CNC machines or inspection machines, CMMs, to do offline training in a safe virtual environment. So those are kind of cool examples of some technology we use that we put into our employees' hands, but we also have some pretty neat products, right? I mean, and these products are again used in the manufacturing industry. If you think about our CMMs are measuring typically a micron or so, and for those folks out there, what is a micron is always a good question. Think of a piece of paper as being about 100 microns thick, right? So some of our CMMs will measure within a whole volume 1 micron, so 1% of the thickness of a piece of paper. And we even have some ultra high accuracy machines that will go to 1/3 of 1 micron. So while it's not a jet engine that's spewing fire out the back end, you're doing things that are just truly amazing from an engineering point of view. And some of the technology is what I think brings people in and keeps them here being exposed to this kind of technology.
Jeff, I've got a follow-up question for you. How have you helped your teams understand what tools are available to maximize productivity? Like, I think this might have had something to do with a story you told once about Madison Square Garden and a project you were doing there. Can you go into that one a little bit?
Which one was it? You might be talking about an Intel center where we were building cords, where it took me 4 hours, took them 12.
I could have that. I remember that story, and I remember Madison Square Garden. I'm not sure where the best moral of the story would be in this case for that particular question. So, Jeff, how have you helped your teams understand what tools are available to maximize productivity? And if you could answer this in the context of one of your projects, I think that would be the best way to describe it.
Well, I mean, the thing about teaching our people is probably one of my biggest issues myself is having the ability to listen. Because I'll be honest with you, the Madison Square Gardens project became extremely successful and accurate based off the ATS 600. And I'll be honest with you, I was negative against it. And until we had a couple of demonstrations and just looking at the opportunities and the technology that's out there and keeping everybody abreast of it. I mean, those are always teaching things for all of us. I mean, none of us we're all students for the rest of our lives. I don't care who you are. And, I'm in my 60s and I'm probably one of the hardest students in my whole organization. But I'm not really, I got so many stories that I've told that I almost can't remember. But Madison Square Gardens was a learning curve. We learned a lot from steel erectors. We learned a lot from engineers. We learned a lot from site surveyors. Just don't ever close your ears and close down on opportunities and ideas because there's plenty out there.
I believe you've said something along the lines of you're able to learn and train on the job and still kick the crap out of the old production numbers. Is that one of your sayings as well?
Oh yeah, we can run circles around people. I love the challenge. I mean, they laughed at me when they thought an old man was going to beat them, and I not only beat him, we killed him. And it's not how hard you work; it's how smart you work, and using the technology. Because when you talk about rework and how you put things, metrology is a control. And if you don't keep utilizing it as a control, you just go back to ground zero again. But that's where you have to always constantly train and keep people because those are the controls that you have to have in place. Otherwise, you're going to get reworked and costs are going to go up.
So, Randy, I've got a question for you. You said part of your approach is the mentality that just because an issue hasn't happened yet, you should still prepare for it, which I think pretty much any manufacturer would agree with. Can you tell us a bit more about that? Like, how do you make sure proactive training is more than just an afterthought?
I like to look at it just kind of in the context of when I'm working with people. I think maybe one of my superpowers is just being able to imagine the worst case scenario that we're doing something and somebody puts the wrong tool in the spindle. Somebody misloads the part and they shift it a little one way, or I think just the myriad of things that could happen. Somebody inverts a number on something and they see something differently, and so I think it's really pretty easy to think back on when someone just made an honest, and I'm going to call it an honest mistake. It wasn't intentional. It just, things happen. They something called out something and they just saw something else, grabbed it, and there was no check. And so every time I'm doing training, I like to kind of look at a situation and go, let's use this as an example. Like, hey, let's say we didn't hit this dimension, or that we this tool broke down too soon, or the roughing tool broke down, or the finish tool didn't do what it was supposed to do. We can put a check in here to come in and measure and update this, and or it can just set a flag and just say, hey, like, come look at me. Like, I think this is a kind of a forward-thinking thought that we had, that if something goes south here, or this whole dimension doesn't hold, this is going to have a cascading effect all the way down. And I don't feel like that's an unrealistic situation. And I like to kind of look at those training situations and just kind of make up a little scenario of like, hey, this is maybe something I saw in the past, or this is something I could see happening in the future. So let's create a little kind of a training session here, and I try and kind of help guide people. I like to try to help lead people to answers, because we, in our respective fields, we're necessarily subject matter experts, and so we know the answer. But I like help leading people to that and getting them to kind of think critically. And I think that just builds confidence. I like to see when people have confidence and they're like, oh yeah, I did this before, and that can apply now. And I think that's it's just not fulfilling and nice to see when people kind of take that little bit that you've given them, and then they latch onto it and they expand, and use it somewhere else. And I think that's not I don't think that that's unreasonable. I think that in any kind of situation where we're doing training, we could look at that maybe from a little bit broader context and say, let's turn this just little question into even just an impromptu 10 or 15-minute training session where someone could gain some valuable information that they didn't have before.
Randy, I've got a follow-up on this. I mean, is there something that you think you've done particularly well at your company that's getting people to ask the right questions, that's getting people to have that willingness to learn on the job, improve processes, etc.? I'd love to hear maybe some thoughts on that.
Yeah, I think just inspiring inquisitiveness, and or like asking ask me something, or what's an outlandish or wild thing that you think we can't do, or that if you had a magic wand, if we could do something, what would that be? And I like to encourage people to think big, like, or what would save you a lot of time and hassle and headache. Like, that's the other thing I love, to like pain points. Like what is a pain point that if you could solve your day, job, problem, whatever, would be much better. And necessarily is it always possible, but I think once you dig in and dig down on that, I think that you really can find solutions that necessarily are not not that difficult, and or if they have inspection probes or software that they can solve those things. They just didn't necessarily didn't know. And I think also the thing too is, I think a lot of projects seem, especially for me, that they're just enormous. Like, you look at a project and it's almost overwhelming. And I like to tell people, it's like, let's just take, right, how do you eat an elephant? One bite at a time. Let's break it down. Let's, look at the small bits that we can help us, dissect that and understand it. And then let's start testing. Are we sure we can do this? We don't know. Let's try it. Let's get in there, take some measurements, do some inspection, record the data. And I think that myself and other people find that it wasn't as hard as we thought, or we really could do that. We just needed to have that confidence and faith, and the tenacity, and just kind of move forward and do it. Get it done. And I think that, and I think that there's also some other, there's some other benefits that come along with that. There's other things that we learn, that we didn't, something we had to research, a system variable, a machine function, a software function that we're now like, oh, like we didn't know how that worked, and now we do. So here's another, tool in our toolbox that we can apply, system wide, I guess I'll say.
Randy, I appreciate you taking us a step further with that answer. Jeff, I want to go back to something you mentioned pretty early in this conversation, and that's the paradigm shift. And I believe a paradigm shift taking place in industrial manufacturing right now. Are you seeing more people with a willingness to change, looking at education as an opportunity to improve their processes? Let's talk about that paradigm shift a bit.
It all depends on the corporate aptitude, really. It's like I said yesterday, we had a wonderful day that, you have a lot of people that are willing to change, because if you're not willing to change and the way you think about things and how you do things, I'm really not interested in working with you. Because what we do is we try to get buy-ins from everybody, and then do some real quick successes, to show them, like a simple one is doing a Kaizen event with the different groups. You got to involve everybody and get the process in place, get the buy-ins, and then show success, and then it's just amazing how fast that paradigm will shift once you get the buy-in of all these groups.
So, Steve, as we wrap up this part of the conversation, based on everything we've discussed, can you summarize manufacturing operations in the context of three things that we've talked about today, but not necessarily all at once? People, parts, and process.
Yeah, I think next year will be 35 years I've been living, growing, and working in manufacturing. So I've had the opportunity to do lots of fun things. It was probably about 10 years ago that we had a product launch, and it was a bit premature. The product wasn't technically ready, and supply chain wasn't set up, and it was one of the most challenging times of my career. And I found it just about everything that could go wrong was going wrong. And I had one of those days to come in and say, how do I wrap my hands around all this? And it came down to people, parts, and process, the three Ps. And any challenge I've had in my career since then can be kind of addressed through the three Ps. The first P, of course, is people, which is the most important. Having the right people, the right attitude, the right education, right willingness to learn and grow, fostering an environment where they enjoy working, where they understand what the goals are, having good communication, again, having an environment where those people are going to thrive. That's really where it all starts, right? Once you've got people in place, parts are the next P. And we're all dealing with some pretty challenging times right now. So supply chain and can be very, very complicated in terms of local sourcing or foreign sourcing. And that is a very tricky part. There's no magic pill there. Like, you have to be flexible and be able to pivot and react to different things that are happening. Suppliers are always coming and going. They're all having their own different challenges. So again, having options, typically having a good first source and a good second source, always have a backup, is really the advice I'd give on the parts side. And then third is, we've got people and all the parts are there. You've got to put them together. You want a dependable, repeatable, consistent process. This is where metrology kind of comes in. You've got to measure what you're doing, understand what you're doing, have good metrics to understand if you're on track, if you're trending in or out of control. This touches on things like work instructions and process control, fixtures and jigs, and all the things we talked about earlier. But when you put those three things together, it can be a nice little guidepost for you to kind of sort through whatever is thrown at you in a manufacturing environment.
Well, one other aspect that we haven't touched on today that I want to ask you each about is a little around your careers, because, and I hope this has come across in the conversation, you all have a lot of enthusiasm around what you do. Like, a lot of you have been doing it I say everyone on this call, we've been all doing it for quite a while, and I'm interested to hear what keeps you all going in this space, particularly in a conversation that's been so focused around measurement, which when I think of excitement in engineering and measurement, those aren't necessarily the two things that first come to mind, but you all seem to buck that perception in your own unique way. So Randy, I'm going to ask you first. You're a third generation machinist, so this is in your blood. What has given you lifelong satisfaction in this manufacturing and engineering space?
I think for me, I think the beauty of manufacturing is that it has so many different facets. Like if you're, micro machining, aerospace machining, composites, medical, any type of weird, fabrication. There are just so many, and I think different ways to make something and different ways that we do make things, and so many different, parts and processes, and even I think what's the old joke, you get 1 part and 10 programmers in a room, and you'll get 10 different ways to make a part, and and many of them will probably be more than likely correct. And so I think that there's a lot of creativity that goes along with that for people like myself. I don't think I have an artistic, bone in my body, but taking a raw piece of stock and coming out with something that, we look at together and go, it took so many 10 different people, put their hands and work on this, and then, we have this thing here. And I think for me, a lot of those parts are beautiful. Like they're just amazing to look at. And when we think about the things that we create and then, inspect and measure and, put life and energy and work into, it's just, I think it's amazing. Like really honestly, it's amazing. And I think that, again, with the depth and breadth of manufacturing, if there's a sector that you've been in for a while that maybe you're losing interest in, there's always another, there's another field, another facet, something else, another field that we're not an expert in, that we can learn, that we can learn from and grow in, that can, I think, recapture that imagination. And, for me, just programming and has just always been fun. It's always just been exciting, and I enjoy it. And the industry is changing, the software is changing, the way we do things is changing. And so, that keeps us on our toes, and I think adds that excitement and that challenge to go and tackle those problems. And it's, and it's nice when you have a little leeway, when someone, gives you the room. It's like, hey, I've got this problem, and, maybe here are some guardrails, but then, solve it. I think that all scratches that creative itch that we have. And I think I wish I want people to encourage that, right? I think that's what, when people can really start exercising their brains and problem solving, I think that, kind of reinforces what they do and makes them feel valuable, and creates that confidence in yourself, and then I think, encourages you to go forth and, tackle, more challenging projects.
Well, I appreciate you touching on the artistic side of engineering there. Jeff, you're in your 60s, and you talk about how you're still walking around these steel mills doing the heavy lifting there. Your sons are mechanical engineers. Your wife is the company president. What keeps you going in all of this?
Well, the bottom line is I like to see people succeed. I like to see companies succeed. I like to be in a part of being the best, at what we do, and watching people become successful themselves, because success begets success. I mean, what's made us so successful and never bored is the people that we've trained have gone on to larger roles in other corporations that constantly give you a phone call. It's all about people for us, and especially for me. I mean, I've been blessed all my life, and one of my mentors told me a long time ago, he says, we invested a lot of time in you. You make sure that you invest a lot of time in the people that come behind you. And I mean, that's what it's about.
Well, two great summary answers that highlight your enthusiasm around this space. Steve, take us home. What's your final reflection or piece of actionable advice for the listeners out there today?
It's a lot of pressure after those two good answers. Those are both great ways to wrap it up. I think that, as I reflect on U.S. manufacturing for a minute here, there's a lot of fear and uncertainty right now. Today happens to be one of the days where the tariffs are top of subjects. I think this is and should be an opportunity for everyone. There are lots of companies that are trying to do more in the U.S. And I think that it's been difficult. We've lost some of the edge we had years ago. We had been and have been the leading manufacturers in the world, and maybe arguably we've lost some of that. Now is the time for us to buckle down, invest in technology, invest in our people, doing the cross training, the mentoring, so we can establish the future workforce of our industry. Now is a great time again to invest in technology and tooling to make us more efficient. We have the capability and the possibility to be top of our game again, I believe, if we make those investments. So I would encourage everyone listening to, don't be afraid and close up shop and go home. Now's the time to buckle down, invest, learn, train, and grow, and rise to the occasion.
Well, I appreciate how the three of you have tied investing in your people, learning on the job, and adopting technology to the satisfaction that you have in your roles, as well as the success of your companies in this conversation. So, hey, Jeff, Steve, Randy, thanks for taking the time today. Stay innovative, stay thirsty. Appreciate you being a part of Manufacturing Happy Hour. Cheers.
Thank you. Cheers.
Thanks, Chris.
Thank you a lot.